Hello, physics students. Now that we've learned about the different types of light, we are ready to start learning about stars. And light is very important when it comes to stars and learning what material is in stars, what makes a star. Okay, so for our video today, we have our physics objective. Oops, ignore this date. This is incorrect. Our physics objective. I know why stars are different colors. Okay, that's what we're going to try and learn today. Mr. Thrasher has a what do you think? And it says light moves from the sun to the earth. How much time do you think it takes for that light to go from the sun to the earth? So here is Earth, right? Maybe here's San Mateo. Here's San Mateo. Here's the sun. Light is created by the sun and it travels to the earth. Now this is a big distance, 93 million miles, a very big distance. Now, how much time, tiempo, do you think it takes light? Whoops. How much time do you think it takes light? Do you think it takes seconds, segundos, minutes, days, a year, 1,000 years? You might write, I think it takes light 10 years. Or I think it takes light 1 second. What do you think? How much time? We're just making a hypothesis, just a guess. What do you guess? It turns out how much time? Light is very fast. It's very fast. But this is a big distance. It takes light 8 minutes. 8 minutes to go from the sun to the earth. So if you went outside and you looked up toward the sun, that light was traveling for 8 minutes. Interesting. Interesting. 8 minutes to travel. Okay. The sun, and we've said this before, the sun is a star. When you think of stars at nighttime, star. Stars are like our sun. Our sun is just a very close star. The sun is a star. So this and this, la misma, it's the same thing. The sun is a star. They are the same objects. Now, stars are very, very big. Look right here at this picture. Here I have the sun. What is this right here? That's the earth. Now, the earth is, the earth is pretty big, but compared to the sun, oh my goodness, the earth is very, very small compared to the sun. The sun is much bigger than the earth. But, oh my goodness, some stars are smaller than the sun. Some stars are bigger than the sun. So again, look, here's the sun. Now, let's say the sun is this size. Here is another star called Sirius. Look at this. Sirius is bigger than the sun. Oh my goodness, look at this. This is another star, Arcturus. This is the star Arcturus, very far away, but it is much, much bigger than the sun. And look right here, that's Jupiter, the planet Jupiter. Earth is so small, it's not even in this picture. Earth, you can't even see it. But here's Jupiter, here's the sun. The sun is big, but some stars are even bigger. Oh my goodness. So, stars have different sizes, but also stars have different colors. It's a little hard to see different colors when you look outside with just your eyes. But if you use a telescope, if you look at the stars at night, look at this, both of these pictures. With a telescope like this, you might see, some yellow. Look at this, some blue. This one over here, look at that, kind of red. If you have a powerful telescope, like scientists, you can see even more detail, kind of some white, yellow, orange, blue, red. There are different colors. Okay. Stars can be big or small. They can have different colors. Here's a diagram showing different size and different colors. Look at our sun right here. The sun is kind of average. It's kind of medium in size. Some stars are bigger. But also look, some stars are smaller. And then here we see the different colors of stars. Look at this, blue, white, yellow, orange. Different colors. Now remember, our sun makes light like this. It has a lot of visible light. And our sun is the color orange-yellow. Okay. If you remember this graph, remember this shape, it turns out all stars, when scientists look at stars with telescopes, they see that same shape. Look right here. Goes up and down. Again, up and down. Sometimes taller, sometimes smaller, but they always have this shape. The sun and all the stars have this shape. Interesting. Now, what makes stars different colors? This is what we're going to try and learn. So what makes stars different colors? Mr. Thrasher's going to go to a website. Right here. Look at this. This is the same curve that we saw before. And this is showing the different types of light. Look at this, ultraviolet, visible. This is the same graph. How much light and the types of light. Infrared, maybe radio is over here. Now, Mr. Thrasher can change the radius, the size of the star. So here's our star. Okay, it can be big, it can be little. Grande, muy pequeño. I can also slide this. Look at this. Look, now the star is like orange, kind of brown, difficult to see. And now the star is blue. What is changing? What is changing that makes the color change? Look at the graph. The graph is changing also. If the graph is way over here, that's making it blue. If the graph is way over here, that's making it orange. Interesting. So you can have different colors. Okay, let's think about temperature. We're almost done with this video. Okay, we are used to temperature from like outside. On a nice day, maybe you've seen Celsius before, Fahrenheit. There's another measurement for temperature, and that's Kelvin. It's not very important, but scientists use Kelvin when they measure really hot things. So, bigger number, bigger temperature. So, on a nice day, okay, a certain temperature. Ooh, the oven can get even hotter. So on a nice day, that's 300. You don't need to memorize these numbers. But your oven can get, hotter, right? It can cook food. Here's 450. Fire. Fire is very hot. More hot than an oven. It's 858. Fire's hot. Hot lava. Even hotter. Oh my goodness, look at this number. 1,400. Very, very hot. You would burn. Don't touch lava. What about our sun? Oh, you can't see the number. The surface of the sun, not 1,000. The surface of the sun is 6,000 Kelvin. Oh my goodness, 6,000 Kelvin. And, sorry, Mr. Thrasher kind of has this cut off a little bit. There we go. So there we see the surface of the sun, 6,000. But inside the sun, that's 15 million. So stars are very, very hot. They are very, very hot. Hotter than lava, hotter than fire. They are the hottest things in the universe, the stars. Okay. Now, if I go back to my animation, how was I changing the color of the star? If you notice right here, what am I changing? It's the temperature. So I can make the temperature really hot. Look at this. Look at that, 27,000. And it's blue. I can make the temperature smaller, 2,000. Still hot, but smaller. That makes it red and orange. So the different color stars are coming from different temperatures. This is a little difficult. So there are different color stars. There are different color stars because they have different temperatures. Okay, so let's take a little bit of notes. We learned that objects can reflect, absorb, and scatter light. Something new. They can also create light due to temperature. If you get hot enough, you can create light. Temperature is how hot or how cold something is. And for stars especially, different temperatures create different colors. For stars, the bigger the temperature, the more blue. Interesting. The more blue they appear. Sorry, this is cut off a little bit. Last one. A star's color is based on its temperature. So is a star, if I go back here, let's look at this picture. Look at these different colors. Different colors mean the stars have different temperatures. Some are hotter than others. Some are colder than others. That's what determines color. Okay. That's a little difficult, and we're going to do more practice with that. Don't worry. Okay, but that's the end of our video. We learned a little bit about stars. They are big. Some are bigger and smaller. There are different colors, and most important, the color of the star, that comes from the temperature of the star, how hot or cold. That's the end of this video. Thanks for watching.